Hello, so in this lesson we are going to be solving rational equations. And what makes something a rational equation or a rational expression, once again, is that there must be a variable. There is a variable in the denominator. So it can't just be a fraction that has a number in the denominator. It must have a variable in the denominator in order for it to be a rational expression. And in order to be an equation, you have to have an equal sign. So far, we have dealt with just rational expressions and simplifying and multiplying and dividing and adding and subtracting. So one method of solving rational equations is one that you should be familiar with, and that's basically cross multiplication. So cross multiplication basically is a method of solving rational equations that have, and this is very important, one and only one, so only one fraction on each side of the equation. So basically so one of the bases of, so only one fraction on each side of the equation. So cross multiplication basically looks like this, and we use it in proportions, we use it with probability, but if you have one fraction on the left side of your equation and one fraction on the right side of your equation, basically it says that A times D, so the numerator from one side of the equal sign multiplied by the denominator of the other equals the numerator on the right side of the equation times the denominator on the left side of the, oops, not D, B, on the left side of the equation. And we're going to come back to this in a little bit and explain why that actually works. But for right now, we're just going to apply it. So in your first example here, we have 3 over 5x equals 2 over x minus 7. So again, I have a single fraction equal to a single fraction. So to solve this, I'm going to take the numerator, which is 3, times the denominator of the fraction on the other side of the equals, and set that equal to 2, which is the numerator on the right side, times the denominator that's on the left side of the equation. Now you do need to simplify. In the left side, you're going to distribute. 3 times x is 3x. 3 times negative 7 is negative 21. 2 times 5x is 10x. And then since this is now a linear equation, so it is important to pay attention to what type of equation that you have now. If your new equation is linear, then you want to get the variable on one side of the equation, the constant on the other. So I would subtract 3x to both sides, which would then give you negative 21 equals 7x, divide by 7 on both sides, and I would get negative 3 is equal to x. Now, one thing that you must be careful of when you are solving rational equations, you still have to keep in mind that the denominator cannot be 0. So if you look at each of these denominators, on the left side, you have just 5x. So the only value of x that would make the denominator equal to 0 would be 0 itself. 0 times 5 would make the denominator 0. So I would make a statement saying x cannot equal 0. So if I had gotten a solution of 0, then my answer would be no solutions. Also, on the right side of the equation, you have a denominator of x minus 7. So the only value of x that will make this denominator equal to 0 would be 7. So I could also state that x cannot equal 7. So again, my solution is neither 0 nor 7, so I have checked my solutions. So that's what the check your answers mean, that you need to check your solutions just to make sure they are not going to give you zeros in the denominator, which would make the fraction undefined. All right, so that's example 1a. Moving on to example 1b. So in example 1b, we now have a numerator of 1 times the denominator on the other side of 11x plus 8 equal to the numerator on the right side, x, times the denominator of 2x plus 5. So at this point, again, we would want to distribute. Well, if you're distributing a 1, nothing's going to change there. But when you distribute this x to the 2x plus 5, you're going to get 2x squared plus 5x. So pay attention. At this point in the equation, we now have a quadratic equation. When you have a quadratic equation, you do not want to get the x's on one side and the constants on the other necessarily, unless you don't have any middle terms. However, when you have an x squared term and x terms, many of these equations that are quadratic, you have to get them equal to 0. You also want to keep your x squared term positive. So I am going to subtract 11x to get rid of the x's on the left side, and then subtract 8. There are no constants on the right, so I'm just going to kind of tag it along at the end, so that we now get an equation that has 0 on one side equals 2x squared minus 6x minus 8. Now we use our rules of solving quadratic equations. So one of the processes of solving a quadratic equation is by factoring. So if I look at my trinomial here, they all have a factor of 2. So I would want to factor out the 2. When I factor out the 2, I get x squared minus 3x minus 4. Then I'm going to factor that denominator, or that trinomial, into x minus 4 and x plus 1. So the 2 now in front, keep in mind that there is no x with this. So if we were to take the factor of 2 and set it equal to 0, there's no solution that goes with it because there's no variable. So we can just ignore that 2. But if we take the factor of x minus 4 and set that equal to 0, we do get a solution of positive 4. If we take the factor of x plus 1 and set that equal to 0, we get a solution of negative 1. So those are our possible solutions. So just like with logarithmic equations that we were doing not so long ago, with rational equations, you have to, again, check for extraneous solutions. So if we were to substitute 4 back into the original denominators in the original equation, would 4 make the denominator equal to 0? Well, no. If we look back at our original equation, my pen size is a little bit smaller here. If we look back at the original equation, the denominator here is 2x plus 5. So from that denominator, I can say that x cannot equal negative 5 halves. From this original denominator, I would say x cannot equal negative 8 elevenths. So neither one of the solutions that we got were either one of these. So we checked our solutions. And of course, you could plug 4 or substitute 4 back into the original equation and make sure that the left side of the equation does equal the right side. And you could also do the same thing with negative 1 if you want to double check your solutions to make sure that they are correct. Okay, the next problem that we have is a story problem, because rational equations are used a lot in story problems. And this problem is a little bit confusing, but I'll try to break it down for you as easily as possible. So they've got a lot of information, but basically you have, say, an alloy is formed by mixing 2 or more metals. So we've got sterling silver, which is an alloy composed of 92.5% silver and 7.5% copper by weight. And you have 15 ounces of 800 grade silver. So it's just a type of silver. So the 800 grade silver basically says it's 80% silver and 20% copper. So you've got these two, you've got sterling silver is the one type of silver that you have, and then 800 grade silver. They both contain silver and copper, but they contain different percentages of them. So you have to answer the question, how much pure silver, so pure silver is like 1000 grade or 100% silver. There's no copper in it at all. So you want to know how much pure silver you should mix to the 800 grade silver. Remember that 800 grade silver just means that it's an alloy made of 80% silver to make sterling silver. So we want to go from 80% silver to 92.5% silver. So we have 15 ounces of 800 grade silver. So the question is, how much pure silver should we add? So that's where our variable is going to come. I'm going to say x is equal to the amount of pure silver. So that's 100% silver, no copper, pure silver that we add to the 800 grade silver. Again, 800 grade silver just means that it's 80% silver. So we want to, again, go from that 80% silver to 92.5% silver. So if we set up a proportion, we basically want to, which our per cent formula, it's probably been a while since you've seen this formula, basically, but your percent out of 100 is equal to the part over the whole. Okay, so what percentage do we want? We want 92.5% silver. So we want 92.5 out of 100. That's what we want, because we want it to be sterling silver. We want that 92.5% out of 100, or 92.5% silver out of 100. Now, what we need to figure out is what we have. So we have 15 ounces of 800 grade silver, but that is only 80% silver. So if we want, okay, so we need to figure out, this is a little more complicated than I thought it was going to be, but we want to figure out how much actual silver we have in this 15 ounces. So if you have, let's see, so this is actually going to take a couple of different equations. All right, so let me figure out, back up here a minute. So we have 80% of 100 is equal to what part? So actually, I'm going to let this be N. So let's say N is the amount of actual silver that we have out of the 15 ounces. So 80% of 100%, 80% of the 15 ounces is silver. So we need to figure out, well, how many ounces is that? So we set up this cross multiplication problem. So 80 times 15 is 1200, and that would equal N times 100, or 100N. So if I divide now by 100, you're going to solve for N. So N then is equal to 12. So what does that mean? That means out of this 15 ounces, 12 ounces, so OZ for the ounces, 12 ounces of silver, of pure silver, are in that 15 ounces of 800 grade silver. All right, lots of numbers floating around. Okay, so now let's go back to we're going to do another proportion, but this is what we want. So we want to get 92.5%. So 92.5 out of 100 is the amount of silver that we want. We have 12 ounces. You have 12 ounces of silver in that 15 ounces total. So now we throw in the x. The x is the amount that you're going to add. So we're adding pure silver. So this is the top number here represents the amount of ounces of pure silver that you have. So we found that we have 12 ounces of pure silver within that 15 ounces total. Remember, some of that 15 ounces is copper. So 12 ounces of that 15 are pure silver, where 3 ounces of that 15 are copper. So if we take the 12 ounces of silver plus X, which is the amount of pure silver that we want to add, that also gets added to the total amount. So now we have our cross multiplication problem. So now it's just a matter of solving this. So if I take the 92.5 times the denominator, 15 plus X, that is going to equal now 100 times the numerator over here, 12 plus X. Then we would distribute on both sides. So the 92.5 times 15 is 1,387.5 plus 92.5x, and that is going to equal 1,200 plus 100x. All right, so now it is a linear equation. We don't have any x squareds. So we're going to get the x's on one side, constant on the other. So I would subtract 92.5x to both sides. And then I would subtract the 1,200 to both sides. And that would eliminate, that would go away. So now my new equation would be, so if I take the 100x minus the 92.5x, I get 7.5x equals the 1387.5 minus the 1200 is 187.5. And then you would divide both sides by that 7.5, which reduces. And now we get x, or the amount of pure silver that we have to add, will equal 25 ounces of pure silver. So that's kind of a lot of ounces. So we have to put a lot more silver into this 800 grade silver in order to make it sterling silver. All right, so there are a couple story problems on your assignment. Maybe I'll help setting them up. I'll help you guys set them up when I'm done with the notes here. All right, hopefully I didn't lose you there, but this next example, we are again solving a rational equation, but this time instead of, and this is very important, this is the second type of method that we're going to use for solving rational equations. This is a very important one, and that's using a least common denominator. So we were introduced to least common denominators of rational equations when we were adding. So if you have a denominator, this is very important. If you look at this equation, both denominators are the same. So if you have a fraction on the left that's equal to the fraction on the right, and the denominators are the same, do you really need to cross multiply? Well, the answer to that question is a big fat no, you do not. If your denominators are the same, then by the rules of equality, property of equality, then the numerators should also be the same because they are equal. So what's nice about that least common denominator thing is that once you have a least common denominator in your equation, you can then eliminate the denominator. You don't need it anymore. So if the denominators are the same, if you have the same denominators, then you just set the numerators equal to each other and solve. And it makes it very easy because we don't want to have to multiply this numerator with this denominator. And we would have a quadratic on the left side, we'd have a quadratic on the right side, and then we'd have to get everything to the same side, set it equal to 0 and solve by factoring. That would make this problem a lot harder. But if you have the same denominator, then we just set the numerators equal to 0 or equal to each other and solve. So I'm just going to take the numerator, 7x minus 3, set it equal to 4x plus 6, and solve. So if I subtract 4x to both sides and add 3 to both sides, this will go away, that'll go away. I get 3x equals 9, divide by 3, and x equals 3. So that was a very simple problem to solve since our denominators were the same. Okay, so is there anything else I want to say about that? Nope, other than looking at your denominator, keeping in mind that you do have to check your solutions, light blue here. So the denominator that you have here is 5x plus 1. So the only solution that you are not allowed to get would be negative 1/5. So again, when you're doing these binomials, it's the opposite of the constant divided by the leading coefficient. And if that's confusing for you, you can always take that 5x plus 1, set it equal to 0, subtract 1 to both sides, you get 5x equals negative 1, divide by 5, and again, you get that negative 1/5. But we do not, the problem is we do not want the denominator to equal 0, so x cannot equal negative 1/5. But since 3 is not negative 1/5, then 3 is a good solution. Okay, so when will these type of problems be helpful? All right, so that's right here. So using the least common denominator method, you will use this a lot because not always will you have one fraction on the left and one fraction on the right. So if you look at the denominators for all three of these fractions, this one has a denominator of x, this one has a denominator of 5, this one has a denominator of x, which means your least common denominator has to have a factor of 5 and a factor of x. We can also at this point state what x cannot equal. So looking again at the denominators, the only value that would make the denominator 0 is 0 itself. So x cannot equal 0. So that's step number 1. State the least common denominator and the undefined values. Now we want to make sure all terms have the same denominator. So if we look at the first fraction, now this is going to get a little bit bigger before it gets smaller. So the 15 over x already has a denominator of x. We want it to be 5x. So what do we have to multiply this first fraction by to get 5x in the denominator? Well, 5. And I'm going to put that out front because usually we put coefficients in front of variables. All right, now your second fraction is 4 over 5. So this denominator already has the 5. Well, what does it need to be the same as the other one? It needs an x. So we're going to multiply the numerator and denominator by x. If you look at the fraction on the other side of the equals, it already has a denominator of x. So we just need to multiply it by 5. So this time I put it at the end. Doesn't really matter because all denominators now are equal to 5x. So if I simplify my numerators, so now that all the denominators, all the terms have the same denominator, we can cross out the denominators. We do not need them anymore. So we can just get rid of them. Now you only do this with equations. Do not do this with adding and subtracting. All right, so this will make the problem a lot easier. 5 times 15 now. Let me change my color back. 5 times 15 is 75. 4 times x is 4x. And then 7 times 5 is 35. So now we have a simple equation here. It's a linear equation again. So subtract your 75 to both sides. And we will get 4x equals negative 40, divide by 4, and x equals negative 10 is what we get for our solution. You can plug negative 10 or substitute negative 10 back into the original equation to check it, but I'm just going to check it with my undefined value. Since it does not equal 0, it is a valid solution. All right, so going back here, let's go through our steps again. So the first step was to state what the least common denominator was. Looking at the denominators that you have, also state your undefined values. Then we made all the denominators the same by multiplying each term by whatever it needed to get the denominator to be the same. Then we crossed out the denominators, and we then in turn solved what the new equation that is made from the left, from the numerators. So again, we set the numerators equal to each other, and we solve from there. All right, so here's a couple more examples, a little bit harder. Same idea though. We are going to look at the denominators that we have. So once in a while, you might have a constant or a number that is not a fraction. Well, you can always make something a fraction by putting it over 1. If you look at these other denominators, x cannot be factored. X minus 4 cannot be factored, which means your least common denominator has to contain an x, a factor of x, and a factor of x minus 4. You do not want to multiply them together. Leave them in factored form. And from those two denominators, you can state your undefined values. So looking at the 8 over x, x cannot be 0, or else this fraction would be undefined. This fraction, you have x minus 4, so x cannot equal 4. So that's your other undefined value. So just keep those in mind when you get done solving here. All right, so I'm going to start out by writing down each term, but I am going to put some space in between because I know that I'm going to have to multiply each term by something to make it equal and make it have the same denominator as the other terms. All right, so here's the same equation, just a little bit more spread out. So now I want the top denominator to have an x and an x minus 4. So my first fraction already has an x, which means I need to multiply it by x minus 4 on the top and the bottom. My second denominator does not have either an x or an x minus 4. So we're going to have to multiply this term by x and x minus 4. The third fraction has an x minus 4 in the denominator, so we just have to multiply it by x. So now if you compare all the denominators, are all the denominators equal? Yes. So once they are all the same, we can eliminate them. Go back to your numerator. Now there's a lot of math going on here. You have to distribute the 8, which will then give us 8x minus 32. In this problem, there's a plus sign, so that's good. If it's a minus sign, you need to be careful with your signs. But basically, we have a 3x that we're going to distribute to the x minus 4. So that's going to give us the term positive 3x squared minus 12x. On the right side of the equation, you're going to distribute the x. which will then give you, don't forget this is an equation, so you have to have your equal sign, x squared plus 8x. So this is a quadratic equation. Since it is quadratic and we have x squared and x terms, we need to get 0 on one side of the equation. We also want our leading coefficient to be positive. So I am going to subtract x squared to eliminate that the x squared that's on the right, subtract 8x to both sides, which will eliminate actually this 8x and that 8x, that's convenient. But now I'm going to rewrite my new equation, and I want to put it in the right order. So the 2x squared minus the x squared, I'm sorry, 3x squared minus x squared will be 2x squared. The negative 12x should go next. And then the minus 32 should go after that. And bring down your equals 0 now because we eliminated the terms that were on the right. So now we can solve it by factoring. Factor out of 2, giving you x squared minus 6x minus 16. Then factor that trinomial. It will factor into x minus 8 and x plus 2. There still is a 2 out front, which really, when you're solving an equation, it does not have an x with it, so it will not have a solution with it. We can just kind of ignore that. But your x minus 8, if we set that equal to 0, we will get a solution of positive 8. If you take your factor of x plus 2, set it equal to 0, you get x equals negative 2. So those are your two solutions as long as they don't conflict with your undefined values. So x cannot equal 0 or 4. Neither one of those are 0 or 4, so they both work. Okay, so there's that example. Hopefully you're able to follow that. I wish I had more colors to choose from. All right, let's do green this time. Okay, so this time we do have a minus sign in here. When you have negative minus signs, you do need to be very careful. But let's, again, go step 1. We want x plus 1 cannot be factored. 2x can't really be factored. It's just 2 times x. So your least common denominator has to have a factor of 2, a factor of x, and a factor of x plus 1. So your first fraction has, actually move this over a little bit, 3x over x plus 1. And then the other thing I'm going to do is I'm going to distribute, since this is only a single term, I'm going to change this to a plus and put the minus in front of that 5. So I'm adding a negative 5 over 2x. And then I'm going to leave some space, and then equals 3 over 2x. All right, so now we're going to get those denominators to be the same. Since this denominator already has x plus 1, we need to multiply it by 2x in the numerator and denominator so that this is equivalent to 1. The second fraction, which was negative 5 over 2x, since it already has the 2x, we just need to multiply the numerator and denominator. So that's why I left some space there. We already have a 2 and an x, so we need to multiply it by x plus 1. The third fraction already has the 2x in the denominator, so it also just needs to be multiplied by x plus 1. Oh, also we forgot to state our undefined values. So looking at the denominators or looking at your least common denominator, x cannot be 0 and x cannot be negative 1. All right, so those are what x cannot equal. I guess I didn't need to write the x cannot equal, but okay, so now look at your denominators. Are they all the same? Did you multiply the numerators by whatever the denominator was missing? So once you can say yes to that, now we can eliminate the denominators. And again, I stress, you can only do this with equations. You cannot do this when you're adding, subtracting, or multiplying or simplifying radicals. All right, so now let's simplify. Take your 2x and your 3x and multiply them together, which will give you 6x squared. Then distribute the negative 5 to the x plus 1, which gives you negative 5x minus 5. On the right side, the 3 times the x gives you 3x. 3 times 1 is positive 3. Now, again, we got a quadratic equation, so we need to set it equal to 0. Subtract 3x and 3 to both sides of the equation. So now we have 6x squared minus 8x minus 8 equals 0. Again, we can factor out a 2, which is convenient, making the numbers a little bit smaller, easier to work with. But it doesn't give us a leading coefficient of 1, which means we're not going to be able to factor it quite as easily as we were the others. And I believe there is a problem on here, at least one, that you have to use quadratic formula with one of these. But that's good practice, so make sure you do that problem. But anyway, this is now one that we're going to have to factor with the AC method. So different colored here. So if I take my A times my A value, which is 3, times my C value, which is negative 4, I get negative 12 for my AC value. The other thing we can do here with this 2, we could basically divide both sides by 2, which eliminates it, but this is still going to be 0 over here. So that 2 that was out front, as long as it does not have a variable, we can divide it to both sides of the equation and eliminate it. So now we're focusing on, again, basically factoring the AC method, turning 3 terms into 4. Your 3x squared stays the same. Your last term, the negative 4, stays the same. 2 numbers that multiply together equal 12, but have a difference of 4, are 6 and 2. The 6 needs to be negative, the 2 needs to be positive, and you have to put x's with those to make them equal to that middle term. All right, let's change my colors again. Factor out the 3x, which leaves you with x minus 2. Factor out a positive 2, which also gives you x minus 2, still is equal to 0. Now factor out the x minus 2, put the 3x plus 2 in another set of parentheses. So if we set each factor equal to 0, we would get x equals 2 for one of our solutions, and x equals negative 2/3 as our other solution. But before you move on, you need to check your undefined values. So looking back at the original, we said x cannot equal 0 and it cannot equal negative 1. Well, here we've got 2 and negative 2/3. So both of those are the acceptable solutions. Okay, one more here. I think this is our last example. It is a little bit longer because we do have a quadratic here and we have 3 terms. So you will have to factor some of your denominators. So if we factor this denominator, x squared minus 9 is a difference of squares. It can be factored into x plus 3 times x minus 3. So once I've factored that denominator, I can just kind of cross it out. So basically, x plus 3, x minus 3 is the denominator of this term. Well, this fraction, the first one, has a factor of x minus 3. The third fraction has a factor of x plus 3. And this one has a factor of x plus 3 and x minus 3. So your least common denominator consists of both x minus 3 and x plus 3. Your undefined values that x cannot equal then would be positive or negative 3. Okay, so that's not your answer, but it is leading us, getting us up to that answer. All right, so again, this is going to get bigger before it gets smaller. My first fraction, 6 over x minus 3. I know I'm going to have to multiply the top and the bottom by x plus 3, so I'm going to leave a little bit of space there. And then my equal sign, the 8x squared has a denominator of x plus 3 times x minus 3 already. So since the denominator of this fraction is the same as the least common denominator, we will not need to multiply this denominator by anything. It stays the same. So that 8x squared will not change. The next thing I'm going to do is change this negative to a positive and put the minus in front of the 4x. The denominator originally is x plus 3, so I know I'm going to multiply the numerator and denominator by x minus 3 to make them all the same. Change my color and do that. So this fraction gets multiplied by x plus 3. This fraction already has both. This fraction will get multiplied by x minus 3. So now when you carefully look at all the denominators, they all have a factor of x minus 3 and x plus 3. So they are all the same. Once those denominators are all the same and it's an equation, we can eliminate the denominators and now just solve the remaining equation from the numerator. So distribute the 6 and we get terms of 6x plus 18. Don't forget your equals. The 8x squared doesn't change. Distribute the negative 4x and we get negative 4x squared plus 12x. Be careful to distribute the negative with the 4x. Again, it's quadratic. We're going to get 0 on one side. So I'm going to subtract 6x to the 12x and subtract 18 over here because there are no constants. So those go away. I now have 0 on the left equals, now I do have a couple of like terms here. 8x squared minus 4x squared is 4x squared. 12x minus 6 is a positive 6x, and then I've got this minus 18. So once again, we can factor out a 2, leaving us with 2x squared plus 3x minus 9. We're going to factor this with AC method. Again, we can divide by 2 to eliminate that, but we still get 0. Your AC method, you turn your 3 terms into 4. First term stays the same, last term stays the same. Multiply your A and your C together, which will be negative 18. Two numbers that multiply together to equal 18 that have a difference of 3 are 6 and 3. But the 6 needs to be positive. 3 needs to be negative. So again, if you need to do this crisscross thing over here, so you want your AC to multiply together to equal negative 18, but you want the numbers to add up to positive 3. So again, positive 6 and negative 3 do multiply together to equal negative 18 and add up to positive 3. All right, keep going. Green. Just cut your 4 terms in half, factor out a 2x. I'm going to rewrite this over here. Factor out a 2x from the first 2 terms, which will give you x plus 3 remaining. Factor out a negative 3 from your 3rd and 4th term, which again gives you the x plus 3 remaining equals 0. Factor out the x plus 3, and then you have your 2x minus 3 in parentheses, set each one equal to 0, and x would equal negative 3 for your first factor, and then x would equal positive 3/2 would be your second solution. Again, once you get your solutions, don't forget to go back and check with your undefined values. Well, our denominators were x plus 3 and x minus 3. So negative 3 would make this denominator 0 and would make the fraction undefined. So that is an extraneous solution. So the only solution to this equation, or to this original rational equation, is 3/2. All right, that is the end of these notes. This is a 2-day lesson. So hopefully, if you do the notes one day, you can do the homework on the other, or you can do half the notes today, half the notes tomorrow, and then do the assignment.